In this video, I want to talk about changeover sequencing problems in manufacturing, and I want to look at a single machine problem with a defined changeover matrix that you can see on the screen. So in this case, we have a machine that can be used for producing a sequence or a series of product types referred to here as A, B, C, D, E, F, G, and H. And the changeovers from one product to another are defined with changeover times here in this matrix. And the objective is now to find the optimal sequence in which you want to produce the products in order to minimize the total amount of changeover time, since changeover time is unproductive and basically it generates costs. There are two slightly different subproblems to this problem. One would be the repeated production cycle. In this case, you simply assume that the sequence of products is produced over and over again. And once you reach the last product in the sequence, you start a new sequence and change over to the first product in the sequence again. So this is what I showed here in this illustration. That is just for illustration purposes. So the solution to this problem is not the sequence that you can see here. But let's assume that this would be the optimal sequence. Then after you produce product H, you would then change over to product A and start a new sequence. That would be the repeated production cycle. In the case of a one-time only production program, one of the products would have to be the first product to be set up, and then you would complete the remaining sequence, and the last product in the sequence would then be the last product to be produced in the production program, and the production program would be complete. So in that case, you need some additional input data, which would be this initial setup. So in this case, product A and the time required for preparing the machine to produce product A is not defined by a changeover time, but rather a setup time. And in this slide, you can see a vector here that contains the setup times in case you want to implement this one-time only production program. So for example, if product A would be the first product in the sequence, then setting up the machine from its base state and preparing it for the production of prototype A would take 12 seconds. So two slightly different problems. You could say that the one-time only production program contains a little bit more information, has more constraints, requires more input data, so it's a little bit more difficult to describe it mathematically and to implement it. But both problems are rather easy to define mathematically, and it's also quite simple to implement them. You can implement them, for example, with Excel Solver, which I will show in another video, but you can also use Python to implement problems of this kind. And in Python, you have access to libraries and solvers for free that allow you to both model and also to solve these problems. On my blog, and you will find a link in the video description, you can find a zip file, a downloadable zip file that contains a more detailed case study description of this problem, contains the relevant input data in the form of CSV files, and also contains the Python models and the mathematical problem description. So both a documentation of the mathematical models that are required to solve and to define these models and problems, and Python files that implement the solution. So basically implement these models in Python and allow you to solve the problem. And in this video, I just quickly want to demonstrate these Python models. So I want to show you that I want to show you the result basically to this case study problem. And the first thing I need to do is to update the input data. So in this downloadable zip file, there are two pieces of input data that are required. One would be the setup times. So this is nothing else but the setup times that are shown here on the slide. So each column would be one product type, and the value contained by the respective cell would be the setup time in case this product type is the first product to be produced on the machine. And this is relevant input information if you want to solve the one-time only production program. And in both cases, so in the case of a one-time only production program and in the case of a repeated production cycle, you need to also specify the changeover matrix. So here simply each row is product type. Yeah? The first row would be product A, the second row would be product B, and same goes for the columns. And then the values contained here would be the changeover times. In the case of changeovers to the product itself, I've here entered a very high changeover time so that the solver doesn't. So to make it clear that this is not meant to be part of the solution here. The solver actually doesn't need it because the mathematical model itself will have constraints that assure that there's not a setup to the product type itself, or not a changeover to the product type itself, which in the case of a different production program or a different assumption might actually be allowed. But in these two examples that we look at here, it's not allowed to change over from a product type to itself. But as I said, if you go to the downloadable model description, you will see how to define this mathematically and how to add these constraints in a mathematical model so that it is ensured that there are no changeovers that you do not want. In this case, I just wanted to demonstrate how you can use these Python models to get the solution to this problem. For this, I will switch over here to Visual Studio, and you can see here navigated to the folder, the repository that contains the Python models. This would be the downloadable zip file that you can also find on my blog, and as you can see, it contains a mathematical problem description and a case study description and a documentation of the mathematical models used for solving this problem. And you can also find two Python files here, which would be model.py, which is the one-time only production program, and model cyclic, which is the repeated production cycle. And in addition to that, you have here the input data, which are the changeover times and the setup times. So first, I will execute the first Python model. So for that, I simply execute it, and it will consider the input data that is provided by the CSV files. In the CSV files, you can simply add additional products by adding rows and columns, and by adding this changeover times respectively. So you could add any amount of products to this input file, and the Python model will consider it and output the optimal solution. Let's execute it. And yes, you can see in this case, we're solving the one-time only production program. The total amount of setup times and changeover times will be 90 seconds. The first product to be set up is product A, and after that you would change over to product B, which is referred to as index 1. After producing product type B, would then change over to product type D, referred to here with the index 3. And after producing product type 3 or product type D, you would then change over to product type C. After producing product type C or index 2, you would then change over to product type E, and so on. So the changeover decisions are provided here, and the initial setup is provided here. And here you can also see the last product in sequence, which would be product H in this case. Okay, so this was the one-time only production program. Now, looking again at the content of this downloadable zip file, there's also the repeated production program, or the repeated production cycle. So if I execute this, we will get a slightly different solution. You can see here, in that case, for a full sequence, the total amount of changeover times required would be 113 seconds. And there's no initial setup to be considered. So you simply get as an output the optimal changeover decisions. So if you, for example, produce a product A or index 0, you should then afterwards produce product B, and so on. So that was a quick demonstration of what is possible with Python using mathematical programming. And if you're interested in getting started with this and maybe using this Python template for your own problems in your company or for your studies, then go ahead and check out my blog where you can find more information on this topic. And otherwise, thank you very much for